A very good morning to you guys. My name is Mr. Takudzwa Kuhuni, and today we are going to look at the fetch, decode, execute cycle. The fetch, decode, execute cycle. Okay, this is our main topic for today. So, what is to fetch? Now, to fetch is to look for something, all right? And what is to decode? To decode is to convert from one form to another form. To be more specific, decoding a message, we are trying to change a message into a readable form, something like that. And to execute is more like the results of a processed instruction. All right, so the main job of the CPU is to execute programs using the fetch, decode, execute cycle. And this is also known as the instruction cycle. Okay, it is also known as the instruction cycle. So this cycle begins as soon as you turn on a computer. So the moment you press the power button to turn on your computer, this cycle begins. All right. So to execute a program, the program code is copied from secondary storage into the main memory. Okay. So if we are saying the program code is copied from secondary storage, we are talking of things like the hard disk, etc. Now the main memory here is the RAM, random access memory. Okay, RAM is the main memory we are talking about. RAM simply stands for random access memory. Okay. All right. So the CPU's program counter is set to the memory location where the first instruction in the program has been stored. So, like I told you when we looked at registers in the previous tutorial, we discussed about what the program counter does. Okay, so it is set to the memory location where the first instruction in the program has been stored and execution begins. Okay, so the program counter, says okay, fine. The first instruction is stored up, so the program counter will be set to that memory location. Okay, fine. Open a first instruction, and it is set to point there. So at this point in time, the program will now be running. Okay. Now, in a program, each machine code instruction takes up a slot in the main memory. Okay. Remember, a program is a set of instructions designed to perform a specific function or a specific task. So each instruction will take up a slot in the main memory. Okay, that's the reason why TGT every program in resources are in order to the CPU. These are some of the things that we'll be talking about, like the memory, etc. Okay, so these slots or what we call memory locations, there are slots or memory locations. Each has a unique memory address. Okay, So kuti pasaita complications, each and every slot has got an address yekuti registers, whatever chiri kuda a certain memory location or a certain instruction iri kuwanika pane a certain memory location chinoziva kuti okay fine, this is address 008 or B9 or whatever the case may be. But the main idea is this address anobatsira kuti my instructions kana akureferencwa anoreferencwa from a certain memory location. Okay, so the program counter stores the address of each instruction and tells the CPU in what order they should be carried out. So program counter, instead of carrying the actual instruction, it stores the address of each instruction. So in English, it the program counter. Okay, fine. In my addresses, the next instruction I tell you address number yakati. The memory data bus doing also fambisa those instructions, the actual data, but the program counter in the address could okay fine. The instruction inowanikwa pa address yakati ichipointa where exactly the instruction is. So it does so by the help of these memory addresses. Okay, and the order the instructions need to be carried out. Remember, we might need firstly the address at memory location A and the second address at memory location B. So another reference ne order. Okay, so when a program is being executed, the CPU performs the fetch, decode, execute cycle, which repeats over and over until reaching the stop instruction. So the CPU now is the one that performs the fetch, decode, execute cycle. So I'll draw a diagram for you to better understand this. So here we have what is known as the control unit or the CU. Okay, the control unit. And here we have the registers. And here the arithmetic logic unit shortened to ALU. And here we have the RAM. Or the random access memory. So the decode has got an arrow. Okay, this is the decode. So the arrow goes this way. It comes from registers to the control unit. Okay, then from there with the execute, and the arrow comes from here to here. Okay, then we also have another arrow, which is the fetch arrow. Okay, so this is a basic diagram of what I want to explain here. Okay, the fetch, decode, execute. or the instruction cycle, or the instruction cycle. Okay? Now the fifth thing is, or I can say step number 1, the processor checks the program counter to see which instruction to run next. So the processor is the one that checks the program counter. So the processor checks the program counter to see which instruction is to run next. So like I told you, Kuti, the program counter will be just pointing out the memory location of the next instruction. Okay, so it's the duty of the processor now to check which memory location is pointed out by the program counter. Okay, then secondly, the program counter gives an address value. The program counter gives an address value in the memory of where the next instruction is. In the memory of where the next instruction is. Okay, so the program counter on the other end, input the actual value of an address of where the next instruction is. So like I said, it will point out Kuti, the next instruction is at this address. So it's now the duty of the data bus to extract whatever is in that address to where it is supposed to go. Okay? Then thirdly, the processor fetches the instruction. The processor fetches the instruction value from this memory location. From this memory location. Okay, so now the processor is now fetching the actual instruction using the memory location that it is given by the program counter. Okay, I'm sure you're following. Then number 4, once the instruction has been fetched, it needs to be decoded and executed. All right. So, for example, this could involve taking one value, putting it into the ALU or the arithmetic logic unit, then taking a different value from a register and adding them to, or adding the two together, or adding them together. Okay. This will be an example of decode and execute. All right. So can say once the instruction has been fetched, comma, it needs to be decoded and executed. It needs to be decoded and executed. Okay, e.g., checking one value, and putting it into the arithmetic logic unit or the ALU, then taking a different value, then checking a different value, maybe from a register, and adding the two together, and adding the two together. Okay, so that's an example of a decoded and executed instruction. Number 5. Now, once this is complete, okay, the instruction has been decoded and executed, the processor goes back to the program counter to find the next instruction. So once the above is complete, the processor goes back to the program counter, to find the next instruction. Okay. Now, this cycle is repeated until the program ends. Okay. So number 6, we can conclude by saying this cycle is repeated until the program ends. Okay. So basically, this is the fetch, decode, and execute cycle. Thank you very much for watching, guys. I hope you've enjoyed this tutorial. If you have any questions, please don't hesitate to let me know at my number 0784 002 002. And also, don't forget to subscribe and like my videos. Goodbye.